Hello friends, welcome back for another Data Factory video. We have already seen the Data Factory basics and how to parameterize data pipelines. Okay, now you will tell me the copy activity is not enough to build a complete data pipeline apparently, right? And you are correct. Fret no more, mapping data flows are here to save the day. But what are mapping data flows? Mapping data flows are visually designed data transformations in Azure Data Factory. They provide a way to transform data at scale without any coding whatsoever. You can design a data transformation job using the Data Flow Designer by constructing a series of transformations. You can have any number of source transformations followed by data transformation steps. There are several options in terms of transformations, such as filters, joins, aggregate functions, unions, lookups. You name it, Data Factory has it. Azure Data Factory handles the code transformation and the execution of mapping data flows behind the scenes. Well, at least this is what the documentation says. But we are curious developers in this channel, so let's take a deeper look. Before we begin, let's clarify the difference between pipelines and data flows. A pipeline is an orchestrator and does not transform data. It orchestrates a series of one or more activities like the copy activity. Data flow is one of those activity types. Remember, in our previous video we used the copy activity. In a copy activity you have to configure the source and the destination settings inside the pipeline. On the other hand, using mapping data flows. In a mapping data flow you have to configure all the settings in the separate data flow interface, and the pipeline works more as a wrapper and an orchestrator. Data flows perform row and column level transformations like parsing values, calculations, adding or renaming or deleting columns. At runtime, a data flow is executed in a Spark environment, not the Data Factory execution runtime. Now, a data flow cannot run without a pipeline, but it's not the same the other way around. Below you can see a diagram of a data flow. You have the source, and here you have the sink, which is the destination. And here you perform some joins and some aggregate functions or group by, etc, etc. But now it's time for us to actually implement a data flow like this one, like the one in the diagram. So let's move to Azure portal and start from there. For the purpose of this video we are going to use two Azure resources. A storage account where we have two containers, the input container here which contains two CSV files. One is the location.csv. If you click on the file and then click on edit, you will see the data. We have location ID, county, state and postal code. And if you click on vehicle.csv and click on edit, you will see three columns here. We have the VIN number, the make year and the location ID. So those two CSV files will be used as an input apparently, and then we have the output container, which is actually the location we are going to save the data after the transformation. The second Azure resource is a Data Factory Studio. I have already created Data Factory as a resource and then launched the studio. If you haven't watched my previous video about Data Factory, please do, so you are able to understand how to create a Data Factory and deploy a Data Factory resource and launch the studio. So click on the pencil here and you will see this screen. Now the first thing we need to do here is actually create datasets. Two datasets, one for the input and one for the output. Click on the three dots next to the datasets blade, click new dataset, click on blob storage. We are going to use blob storage because this is where we saved our CSV files. Click on CSV file here, click continue. Let's name it vehicle. And link service, we have to create a new link service in order to connect to our blob storage. Let's call it Azure Blob Storage Link Service Demo. Connect via integration runtime, auto-resolve integration runtime, that's fine. Authentication type is account key. You select your subscription. This is my subscription here, and your storage account. You click on test connection. If everything works fine, the connection would be successful, and then click on create. Here we have the file path that we have to provide for our input data set. Click on the browse here, click on your input container, click on vehicle.csv, click OK, and here you have the input container, and then directory is empty, and then we have the vehicle.csv. We select first row as header because we have headers in our CSV file. We click OK, and we have created our input dataset. Click on preview data if you want to see the data that everything looks fine. Yeah, it does look fine. And we have here, I think everything looks good. You can play around with the configuration apparently when you have a more complicated CSV, let's say. You have the schema here as well, and you can add parameters. If you want to know more about parameters, watch my last video. Now it's time to create a second dataset that would be the output dataset. Again, on Azure Blob Storage, search on the bar Azure Blob Storage, click on Continue. Select the CSV file here, click Continue, name it as output, let's say. Use the same link service that we used last time, that we created just a couple of minutes ago. Remember, a link service is a connection between Data Factory and Blob Storage. We have to specify the container, but we don't have to specify the file name here. We leave it as empty for the time being, and then click the first row as header, click OK, and we have our second dataset. We don't have to do anything else right now. Leave everything as the default configuration. Now it's time to create our first data flow. Click on the three dots on the data flows blade, click New Data Flow. We have here a new canvas. Click on the Add Source, and now it's time to specify our source dataset. Let's call it Vehicle. Then select under here in the drop-down next to Dataset, select your input dataset. That would be Vehicle for us. Options allow schema drift, that's fine. Under the source options, there are many configurations that you can test it yourself and play around with. Under projection, you can find all the data types for each column. Here you can also specify the format. For example, location for us, location ID is not a string, but it's an integer. Right, here you can specify the format, but we don't need to do that in this case. It is just an integer. Under optimize, you can select your partition option. For the time being, we are going to use current partitioning. I will tell you why in a bit, you will see. And under inspect, you can see the data types again after we change the data types in the projection tab. And we have the data preview tab here, which allows you to see the data. The data preview tab allows you to check your data in its separate step. Now, instead of having to run the whole pipeline to see the results, you can also debug. If you use the data preview tab, you can see your data in every step. But in order to enable the data preview option here, you have to turn the debug mode on. Click here and click on the integration runtime. Now that's fine. Click debug time to live 1 hour and click OK. So it will take a couple of minutes to actually enable the debug mode. Just bear in mind, to enable the debug mode, a cluster has to start, so it's kind of expensive. Remember to turn it off when you are done debugging. It's a bit slow to enable the debug mode, which could be quite annoying when you have a tight deadline and the time is limited. But yeah, this is it. Now click on here, the refresh here, and this will fetch the data that we have in the source. It's not going to bring all the data. Fortunately for us, our CSV file only contains a few records, so it's going to bring everything back, but it brings back a sample. Here we are. We can see our data. Now, if you click on the Add button here and click on, let's say, let's create a conditional split just for the fun of it. Let's call this stream 1, actually split 1 and split 2. Here next to split 1 there is a condition. If you click the Open Expression Builder, it will open this window, which allows you to use functions in order to perform transformations. Now, if you click on functions, you will see all those typical functions: absolute, add days, add months. All these are Scala functions, as Spark, Apache Spark is being used under the hood. Now let's filter the data. For example, we have location, ID, which is our column, greater and equals to 2. Save and finish. And then you can use, I said again, you have these partition options. The inspect that gives you the data types for each column and the data preview tab. So if you click here and click on refresh, you are going to see the filtered data. So we have everything except one. As you can see here, there is no one for location ID. So we filtered the data. Now it's time to actually create a new column. So we click on derived column here. Click that button, derived column. Let's call it, derived column, derived vehicle columns. And then here we have to create a new column. Let's call it make. And click on the enter expression here. Again, open the expression builder. And we are going to write an expression here to remove the year from the end of the model of the make. So we can do that by using the left function, string to subset. So we take the make year column, and then here we need to use the length function and use make year -4. So we are taking away the last 4 digits, which is the year. We don't want the year, so this would give us only the make. Great. We click save and finish, and let's add one more column, and that would be the year. Click on add, then another column, click on year, enter expression, open the expression builder again, and this time we need the right function, the make year and 4. So that would take only the 4 right characters. Click save, click on data preview, click refresh, and it will give us the new data. It is fetching the data. As you can see now, we have 2 more columns. We have the VIN number, the make year, the location, the make, and the year. So essentially, we split the make year here into 2 separate columns, make and year. This is very, very simple. We click on add, and now it's time to use the sync activity because we want to save the data, the transformed data, to our destination. Click sync vehicle, then select your dataset. That would be output dataset. Allow schema drift, that's fine. Under settings, we can clear the folder. I always do that, so I don't have to manually do it afterwards. We have the errors tab. You can play around with that. We have the mappings, the optimize. We are going to use, again, the use current partitioning. You will see why. Inspect, now we have 2 columns. Actually, we have, sorry, 5 columns. And we have the data preview. Click on refresh. And here is our data. Now, we have split 2. That means everything that doesn't belong to this condition, location ID greater and equals to 2, it goes to split 2. So imagine that as a case when statement in SQL or an if-else statement in Python. So in split 2, then we can preview the data here, click on refresh, and it's going to bring back the data again. From the drop down, click split 2, and you will see only one record with location ID 1, right? And then click on the add button and click on sync. Actually, at this point, I want to show you how to export your data into a single file and not use the current partitioning method or strategy to export your data when you have small or medium-sized data sets. So under sync, click on the output dataset that we created before. Let's call that sync output 2, let's say. Under settings, for the file name option, click on output to single file, right? That would be output 2.csv. That would be your output, the file that you will export the data to. Output.csv, you can clear the folder. Actually, no, because we are exporting the data in this step 2, right? We don't want to clear the folder here either. And under optimize, you use a single partition. You can inspect the data again, that our data types, and then click on data preview, click on refresh, and this will give you your one record that we filtered in the conditional split above. Click publish all, and after publishing the data, we are going to create a pipeline, because as we mentioned, we cannot run a data flow without a pipeline. Click on the 3 dots next to the pipeline blade, new pipeline, expand, move, and transform. Now drag and drop the data flow on the empty canvas here, and under settings, select your data flow. Let's call it data flow demo here. We used our data flow, compute size is small, verbose, that's fine. It has a lot of, sync properties, run parallel, staging if you are using signups, etc., etc. The parameters, and I think we are good to go. We publish again, and we are going to use the debug mode to run our pipeline this time. Click debug, click on the empty space here, and click refresh, and it's going to give you, that our data flow demo is running. Click on the glasses, and it opens this window. Here we can see it details for each separate step. Give it some time. Here we are. So if you click here, you can see we have 6 columns when we inputted the data, 1 partitioning, then the conditional split. Again, we have 5 records here that goes into the first stream, and on the second stream it goes only 1 record, and you can see the partitions. Now, if you use current partitioning as a strategy, the default strategy, it's going to split the data into multiple partitions, because remember, Apache Spark is being used under the hood. So behind the scenes, it's not just, Data Factory as we see it, it's Apache Spark. And it's easier later if you use Apache Spark to actually process the data simultaneously when you have multiple partitions. Now, in our case, it didn't split the data into multiple partitions because the dataset was very small. So this is one partition here, and this is one partition as well. Now let's go into our output container, click on refresh, and you will see two CSV files. The first one would be the one with the 5 records from the first stream, and using current partitioning as a partition strategy. And that's why you will see this file name here. It's a CSV file, right? Actually, yeah, you can see it's .csv. And if we had more data, it would give you, part 0001 and .csv or part 002, etc., etc. Instead, if you use the single partition option and you specify the output file, then you can name the file, give you provide the file name you want, and it exports the data into a single file. Let's go back into our data flow. Click here and it will open your data flow. Now again, under optimize, you can use set partitioning. As you can see, there are multiple algorithms here that you can use for partitioning your data: round robin, hash, dynamic range, fixed range, and key, and you can specify the number of partitions, which is a very powerful feature in Data Factory. Let's switch back to use current partitioning, and just for the sake of this demo, let's create another source, and that would be our location data, which is like a dimension table. Click on new because we haven't specified our input data. Click on Azure Blob Storage. Click on CSV. Let's call it location. Link service, use the Azure Blob Storage link service we created. Click on browse. Click on input, the input folder here, and the location.csv. Click OK. First row as header, and we are good to go. Click OK, allow schema drift, that's fine. And let's call it location. Here we can perform a join. So we click on the add button here. We perform a join. Let's call left stream would be the derived vehicle columns, and right stream would be location. Let's perform a left outer join, and let's provide the columns here. That would be location ID. It gives us type mismatch because actually in our location dataset, location is still a string, so this is a string. So but what we can do here is to actually use two integer, and our location at location ID, this is our column, and now you see it doesn't give us an error anymore. Click on the data preview if you want to see the data, and you will see the extra records. You can see we have year, county, state, postal code. We joined based on the location, as you can see here, right? Perfect. Let's publish the changes. Here as well, in the sync activity, you can click on the preview. Sorry, I forgot about that, but it's the same. Now we are going to have more columns in our storage account. Under the output container, let's remove those files, and let's run our pipeline again. Debug. Click on the empty space, click on refresh, You will see your data flow running. Click on the glasses to see all the details for each separate step. And now you will see there is a join here. Click on refresh and you will see the join. Guys, I know that Data Factory is a bit slow, but it's not about, because we have a lot of data. It's because it takes time to compile the package and the code, and this is the overhead, and that's what creates actually the delay. And it takes 2 minutes for those 5 records. Let's go into our output container again and click refresh. We will see now the extra columns here. You can see the county, state, postal code based on the location ID. Perfect. This is it, guys. This is a complete data flow. Apparently a very simple data flow, but if you know the basics, you can start building from there. As we just witnessed, data flows make ETL easy. Transformations become very easy this way, and you use this graphical interface. You don't have to write code at all. But as we mentioned behind the scenes, it is using Spark, that's why it's so powerful. Nonetheless, from experience, I would say for very complex data ETL flows or huge data sets, it's better to use Databricks. This is it for today, guys. I hope you enjoyed learning about data flows in Azure Data Factory. If you like the video, click the like button and subscribe to the channel, and I will see you in the next one.